Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syamil bin Roslan and my metric number is CF230018. The structure that I chose is a railway bridge which is located at Tanah Merah, Kelantan. The local call it as a Taman Jambatan Kereta Api Tanah Merah, which is Jambatan Kereta Api Sungai Melaka, kilometer 475.63. The length of the bridge is estimated as 50 meter long. Next, we can see the support reaction, which is the sketch of free body diagram. This bridge structure requires spin supports and roller support to overcome the forces that the bridge need to hold. The bridge need to hold the forces from vertical part and horizontal part. So the force that applied at the middle of the bridge is 1.57 kN. So we need to find the force at the x-axis and y-axis. So total Fx equals to 0, Ax equal to 0. So total Fy upwards positive equal to 0, Ay plus By minus by 1.57 kN equal to 0, Ay plus By equal to 1.57 kN. So total of moment at point A positive clockwise, so negative 50 By plus 1.57 equal times 25 equal to 0, negative, so By equal to 0.785 Newton. So we take from y-axis Ay plus By 1.57, By substitute to 0.785, so Ay we get 0.785 kilonewton. Next, we need to find the center of gravity. For the shape 1, area is 2000 and x is 0, y is 180 and x is 0, ax is 0, ay is 360000. Shape 2, 3000, x is 0, y is 95, ax is 0, so ay is 2x5000. For the shape 3 is 2000, x is 0, y is 10, ax is 0, ay is 20,000. So the total of area is 7,000. So the total of ax is 0, total of ay is 65,000. So x bar equal to 0 divided by 7,000, so it's equal to 0 millimeter. Y bar 665,000 divided by 7,000, which is equal to 95 millimeter. So the center of gravity is located at 0, 95. Next, for the moment of inertia, shape 1 we got Ix for shape 1 is 66666.67, for Iy is 1666666.67, so dx is 0, dy is 85. For the shape 2 we got 5625,000, Iy is 100,000, dx is 0, dy is 0. For shape 3 is 66666.67, for Iy is 166666.67, dx is 0, so dy is 85. For the calculation of Ix, we get the total of Ix for moment of inertia from Ix. So to find the moment of inertia from x-axis or y-axis, we need to plus between Ix plus area multiplied by dy power of 2. So we get for the total of shape 1, 2, 3 of Ix, we get 3458333.34. So for the Iyy 3433333.34.
My name is Ahmad Farid bin Zainuddin. My matrix number is CF230005. The element structure that I choose is dams, and it's located at the Columbia River west of Spokane, Washington. This dam was one of the largest structures ever built by mankind. A mass of concrete standing 550 feet high and 5,223 feet long. For the next slide, as you can see, the free body diagram that I sketched for dams that I choose, and for the right side in this slide it shows for support reaction. Support reaction. The dam structure requires spin support and roller support to overcome the force that the dam need to hold. The dam need to hold force from vertical part and horizontal part. Force that labeled as Ax receives force from horizontal part. Force that labeled Ay and By receives force from vertical part. For the third slide, centroid of gravity. As you can see at the table, we have 3 sections. Centroid of gravity for the x-axis, we have 6.5 mm, and for the y-axis, we have 10.7 mm. At the below, that's how I calculate for the initial moment. And for the right side, as you can see, that's formula that I use for the moment. Conclusion. We can conclude the support reaction, centroid, and the moment of inertia have been calculated, and the values of For all of it, very logical, accurate, and reasonable. Last but not least, in designing a big or small structure, we must be smart and careful in deciding the material, size, strength, and durability, because with all of these are very important to make sure the structure are strong and safe for user when using it for a long period of time. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Ashraf, number metric CF230143, and my element structure is a water tank. So I want to talk about my water tank that I choose. A water tank is a container designed to store water, and water tank can be made from various materials such as plastic, metal, or concrete, and come in different capacity based on need. Water tanks are used to store clean water for household, agricultural, industrial, or other purpose. In some cases, water tanks are equipped with pumping system to distribute water to various locations as needed. I have chosen a tank with width of 5 meters, height of 3 meters, capable of holding up to 5,000 kiloliters of water. The tank is constructed using a combination of metal and concrete material, and it features fixed support to ensure stability and structural safety. So this is free body diagram and action loading on the water tank support. The picture is my sketch about free body diagram of the water tank. This water tank structure requires feet support to withstand the force imposed by the tank. The tank needs to endure force from both the vertical and horizontal component. The force labeled as AX receives force from the horizontal component. The force applied at the middle of the tank is 50 kN. Force labeled as AY receives force from the vertical component. However, the data pertain to a water tank with feet support and a load of 50 kN. So this is a centroid of gravity of the ship. So how to find the centroid of gravity? I just made a table that have a shape area x, y, ax, and ay. So first I just find the rectangular area for the x and y. We just find the distance from point started to the middle of the shape. And then for the ax and ay, we just area time by x, and we get ax and ay. So and then use the formula of center of gravity is total of ax divided by total of area, and then we get a centroid of the gravity of the ship. So this is moment of inertia from the shape. I made a table also that have a shape area is prime, iy prime, dx, dy, ix, and iy. So to find the ix prime is use the formula 1 over 12 times length and time height power of 3. But to iy prime is 1 over 12 times length power of 3 and time height. And then I get the ix and iy. For the dx and the dy is the distance from the centroid. So my and dx I get 0 because it's just one shape and it's rectangular. For ix formula is ix plus a dy power of 2, and formula of iy is iy plus a dx power of 2. And I use the formula to get the ix and iy, and I get the total for it, and I get the moment of.
Assalamualaikum. warahmatullahi wabarakatuh, and hello everyone. I'm Muhammad Faiz bin Ahmad. My metric number is CF230206. Okay, today I would like to talk about a structure. The structure is Kampung Gua Bridge. Okay, what about the bridge? The bridge is located at Kampung Gua Mano, Kuala Kangsar, Perak, Malaysia. Okay, the bridge is using 600mm ball pipe for their support. The depth of pipe is based on the field. That means the hard rock material at the bottom of pipe. The pipe has been socketed 1.5 to 3 meter into the rock. The ball pipe is to provide support for the structure by transferring the load to the layer of soil or rock that has sufficient bearing capacity and suitable settlement characteristics. The type of the bridge is integral bridge. The integral bridge doesn't have expansion joint and bearing. Okay. Using 7 numbers of 60-meter length pre-tensioned I-beam for the support is to carrying the load from the beam by compression vertically to the foundation. Okay, the structure, the type of support reaction of the bridge is 1 pin and 1 roller. Okay, what about the function of this bridge? The bridge is one and only way to connect people around to the town. The existing bridge is too small to accommodate high dense population around that. Okay, this is the location for Sungai Gua Bridge. This is Malaysia map. That we can see the arrow show the location Sungai Gua Bridge. Okay, this is the coordinate of the bridge. Okay, this is the detail of location Sungai Gua Bridge. Okay, we can see that this existing bridge Sungai Gua is too small and not unsuitable to carrying the high population dens around that. Okay, we can see the new Sungai Bridge. That we can see the length is more length and more wide than the existing bridge. Okay, this is beam location at site. The beam has been launched into the at the beam seater. Okay, this the dimension of I sectional beam. This is free bodies diagram I sectional beam. Okay. We have 9.05 kilonewton per meter. This means every 1 meter, 9.05 the force is applied. Free body diagram FBD for I sectional beam. Okay. When we get distribution load, we have to multiply by the length of the structure. This means times by 60 meter, and then we put to the middle of the beam. Okay, we can see the calculation show. Fx equal to 0, Ay plus By equal to 144.44 kilonewton, By 72.22 kilonewton, and then we can calculate the Ay equal to 72.22 kilonewton. Okay, this is the calculation. Okay, now we assume a loader discharge their load using a ramp. Okay, now we have inclined forces. The inclined forces has 35 degree. Okay, this solution. Okay, Fa equal to 0 Ax minus by 3 kilonewton cos 35 equal to 0 kilonewton. Then we get Ax equal to 2.5457 kilonewton, and then sum of Fy equal to 0, we get Ay plus By equal to 146.16 kilonewton, and then we calculate the moment at point A equal to 0, then we get By equal to 73.51 kilonewton, and then we can calculate Ay plus By equal to 146.16 kilonewton, and we get 72.65 kilonewton for Ay. Okay, this is the dimension of ice sectional beam. Okay, we calculate the moment of inertia for ice sectional beam. Okay, firstly we have to find the centroid of the structure. Okay, the centroid of the structure at x-axis equal to 0 mm, and then at y-axis equal to 365.28 mm, and then we can calculate the second moment of inertia. Okay, we can see that the value of second moment of inertia at x-axis and y-axis. Okay, this is the location of the centroid. Okay, thank you very much.
Assalamualaikum and good morning to everyone. My name is Muhammad Faris Aiman bin Aziz, CF 200-217. So today I will present about my project BFC 10103 static and dynamic structure. I take the building of Hal Ehwal Plaza, UTHM. So what's about this building? This is a Hal Ehwal building at University Tun Hussein on Malaysia. So the location at Pariraja, Johor. This building was approved its establishment at 1 January 2003 by Executive Committee Quito at 29 November 2002. The height of the building was assumed at 6 meter and the width was assumed at 13 meter. HEP UTHM also have a structure component such as column, beam, trusses and something else using the concrete according to established standard. Function of the building is to manage student of UTHM. So here the location for HEP UTHM. I search in Google Map. Next is picture of the building. I take for myself, so I put on my slide. So here I show you guys free body diagram and action or loading on the building. I assume that 30 kN as a load from the top, and I assume Y is 2 kilonewton. So next is support reaction. This building type of support reaction of the building is feet support. So there, as you guys can see, Fx is equal to 0, Ax equal to 2 kilonewton, Fy equal to 0, Ay plus By equal to 30 kilonewton, and the moment is, as you guys can see, moment equal to 0. So the calculation is 30 kilonewton multiply 15 minus By multiply 30 equal to 0. So 450 minus 30 by is equal to 0. So for 450 is equal to 30 multiply by. So the by is 15 kilonewton. Ay plus by is equal to 30 kilonewton. Ay equal to 30 minus 15, and the n is Ay equal to 15 kilonewton. Center of gravity of the building at the moment of inertia of the building is, as you guys can see, there is a centroid. So this is the calculation of center of gravity. As you guys can see, x is equal to 15 mm, 15 m, and 15 m, and y is 3 meter. Center of the gravity is, for x axis is 15, and for y axis is 3 meter. As you guys can see, there is a calculation that I do on my project. Moment of inertia from x-axis is 540 meter, and the moment of inertia from y-axis is 13500 meter. So the conclusion is, from the calculation we know that the building required feet support AY and AX, and support to resist forces from the load and to hold the self weight of the building. The load that come from AX contribute to support reaction from S-axis for the building is 0 Newton. The load that come from AX contribute to support reaction from Y-axis for the building is AY 15 kilonewton, and BY is also 15 kilonewton, as you guys can see from the slide before. Next, the center of gravity of the building is 15 is x-axis and 3 is from y-axis. Moment of inertia from x-axis 540 meter, and moment inertia from y-axis is 13500. So I end my presentation here. So I hope you guys can enjoy my presentation. Thank you very much.